Yeah, good morning. Thank you. Thank you so much for joining this session. So I'm Prabhu from PayPal. About me, I manage a big data platform engineering team in data platform organization within the PayPal. So in this session, we would like to share our Spark journey, where we started some 2 years ago, and what are all the challenges we faced when we productionalize our Spark jobs on in a massive scale in Yarn cluster, and how we resolve them, how we address those challenges by building a Spark compute platform, which is a completely REST-based Spark compute platform, and we call it as a Spark Compute as a Service at PayPal. So no need of, I guess, introduction to the PayPal. Hopefully, most of you may have PayPal accounts and use day-to-day activities. So just to highlight the scale we operate, we wanted to share some of the metrics about the business and then our data platform. So PayPal is one of the world's largest internet payment companies with 203 million active accounts, and we operate across 200 markets in the country. So let's say we processed close to $354 billion payment in last year, 2016. And out of that, 1/3 of the transactions are coming from mobile devices. So since PayPal operates worldwide on different platforms, different devices like iOS, Android, Windows, and then different kind of, our PayPal platform, by the way, includes Braintree, Venmo, Credit, Paydiant, Zoom corporations, like that. So because of this, we generate lot of data. And then we are processing 6 billion transactions in 2016. And if you see the year-over-year increase, you can see where I'm going to put the challenges at it. So we are rapidly going. That means we are generating a lot of data every day. And so each transaction is translated into some piece of information or piece of the data. And with tens of Hadoop clusters, hundreds of developers and users, and thousands of jobs, we extract insight for each and every piece of the data to enable our business and to improve it. So coming to the data platform, on data platform, we manage close to 15 plus Hadoop clusters. And that some of them are multi-tenant, some of them are single-tenant, running for different kinds of workloads, different kinds of use cases, and everything. So, and out of that, 2 are really big clusters, which stores close to 70 plus petabytes of the data. And by the way, the 70 plus petabyte, I'm talking about only the 2 clusters. On the whole, on the PayPal, actually, I don't know how much data we have, including the Teradata, Oracle systems, and lot of other storages. And we 70 plus petabyte of the data primarily stored in Parquet, RC file, sequence, Havro formats. And we run close to 40,000 on jobs per day in 5 plus compute engines, like Hive, MapReduce, Pig, and Spark, and Apache Beam. And in the last 2 years, all our new initiatives and new projects are onboarding only on Spark. So we run Spark on Yarn, and this is our deployment model, how we run Spark on Yarn. And hopefully this is not a deviate from yours, I guess, because this is the traditional and usual way of running Spark jobs. So here, the interactive users will log into some of the edge nodes, and then they will submit their Spark application on the Yarn cluster through PySpark CLI or Spark SQL CLI or Spark Cell CLI. And then we use enterprise scheduler to create the pipeline and to schedule the batch jobs and streaming jobs. And we use UC4 scheduler and Airflow, and it's open. You can use any of the scheduler basically to pipeline your workflows. And these are all the edge nodes, not part of the cluster. It's sit away from the cluster where we deployed all the Hadoop libraries, client libraries, configurations, everything for the user to schedule and submit their jobs. So let's start our challenges. I categorize the challenges that we faced in the last 2 years into 4 categories, from administrator perspective, operations, and developers and analysts. And this session it's going to be a technical session. And I have only 30 minutes, but I cannot cover the entire works what we did in the last 2 years, so I will be going only on the high level. But I brought my entire team here, so in case of if you want to have a deep dive session, discuss and want to show some demos, we will be available off the stage after this meeting. And coming to this edge nodes, this deployment model looks pretty simple, like user log into the edge node and submit that application. But think about the PayPal scale. We have 15 plus Hadoop clusters and 250 to 300 edge nodes, and each one will be running different Hadoop distribution versions. And that's put a lot of challenges in for the administrator in maintaining the libraries, configurations, and everything, and maintaining the sync across the edge nodes and everything. And we need to put a lot of, and by the way, edge nodes, some of the organizations may call us like launcher boxes or CLI boxes like that. And the problem is I need to deploy the entire stack of software from Hadoop libraries, client libraries, the Spark, Zookeeper, HBase, everything there, and then different versions and different cluster configurations have to be deployed. And every time when the user runs, they need to carefully use which Hadoop binaries I'm using to submit the jobs to my production cluster, my R&D cluster, like that. And that's not the major problem. The problem is from the user perspective. They will take the copy of that Spark libraries and then they put it, they change the configuration, they change the libraries and everything. From their home directory, they schedule it. And when we are doing the upgrades, that will go out of sync and the user jobs will fail. So we wanted to create more controlled environment how my jobs is going to run in the yarn cluster. If you have your Hadoop cluster in a very good control environment, I'm sure your Hadoop cluster, you will not face any performance issues with the Hadoop clusters. So that's one of the issues. So coming to the developer perspective, so when we started 2 years ago, the data lake project and some other initiatives, we are handling different kind of workloads. Like some of them may be small data set, some of them may be a huge data set, and some jobs will be running for hours, minutes, and coming to latency, we need sub-second jobs also. So say for example, Spark is really good on batch and streaming, where you can start a context and do a bunch of jobs and then come out of the context. But to start a context in a very in a free cluster, it will take minimum 30 seconds to 45 seconds for the application master to start, and then it has to reach out to the resource manager, get the resource allocated, form the executor, ship out all the jars, and then it will start the Spark context, minimum 30 seconds to 45 seconds. And in our case, thousands of nodes, always busy, and if my time is bad, I may be waiting for 30 minutes just to get the context. So in order to address it, say for example, a lot of our SQL, we run major Spark workloads in Spark SQL. So some of the things are like alter table statement, MSCK repair table statement, a simple insert from table 1 to table 2, table 2 to table 3, like that. But I want the SQL itself will run only for a few seconds, maybe 1 second to 30 seconds or 60 seconds, like that. I don't have time to wait for the 30 minutes to get a context and then to run it. So that way we wanted to get the low latency. And one of the good thing is Spark is you can persist the data frame in the cache and then you can reiterate the data set to get the better latency. But unfortunately, you cannot share the persisted data set across the Spark context, but we wanted that one. And then no modularity and easy restartability, in the sense like I can wrap all the SQLs into one Spark job and submit it, because I don't want to start a Spark context for each and every step. That's how the typical deployment happens. But if the third step fails, I need to restart from the step 1, which is unnecessarily wastage of resources. So I want more fine-grained restartability, like, okay, third SQL fails, restart from the third step. And then REST-friendly. We are not only PayPal, a lot of organizations are moving towards like Docker containerization, launching the VMs and submitting the jobs and everything. So in order to submit a job through a Docker container, I need to install all my Hadoop libraries, Spark client libraries, and then the corresponding etc Hadoop configurations and everything has to be packaged, and then I need to start a Docker container to submit the job. Then we were thinking, why can't we start a Spark job without any of the packed container, just launch a Debian, a bare OS Docker container and submit the job. Is it possible? That's our next challenge. And coming to the analyst and scientist perspective, 2 years ago, Spark is well matured enough, but the components around the Spark are not matured enough. So like if you want to run some Spark application through the interactive, the typical way usually the people use like a Spark Cell CLI or PySpark CLI, or some of the team using Zeppelin, but that's all not more efficient in terms of, because Zeppelin will run everything in the yarn client mode. Okay, at the most, how many jobs you can run? You can run like, if it is a, let's take an example, 64 GB RAM, and you are using, each job is using 8 GB for driver memory. At most, only 8 applications can run. That puts a lot of inefficiency in running in the yarn client mode, local mode, and one of the most severe problem that we saw is a lot of users will run in the local mode and yarn client mode itself. The problem is only 16 applications can run. The 17th application when submit, it will throw an error. I don't find a port 4040 to 4016 in that range to bind a Spark driver UI port. And if some of the time, if it is worse, if users are submitting a lot of application or yarn client mode or local mode, you will easily get Java out of lang memory error just to submit that application. So we wanted a more sophisticated multi-tenancy support private workspace. I don't want to share my interpreters, my workspace with others. I want a private workspace, private configurations, like what are all the Spark configuration can I do. In Zeppelin, in interpreter, if I want to increase the Spark driver memory from 4 GB to 8 GB, then it's one more interpreter. Then if thousands of use cases I'm having, I cannot manage thousands of interpreters. And PayPal is very, very, very cautious because it's a financial institution. We are security-wise, our highest priority is security. So all our clusters are Kerberos enabled. And unfortunately, at that time, all the components around the thing does not have the Kerberos support. So we were forced to add Kerberos support to each and every component around the Spark. And operations and security perspective, anybody will submit the jobs in any kind of ways. Like there is no unified way of job submission. Some, say for example, one team will write a wrapper on top of the Spark submit, and they will use that wrapper to submit the job. Another team completely using a different way. When it comes to the batch operation, if the scheduler job, one of the pipeline fails, our operation team doesn't have more flexibility to fix that issue. Always they will reach out to that SAE, subject area expertise, to fix that issue. What we need is the better control from the operation perspective. Whatever the Spark job fail, I need to address it and restart it in a very easy way. That's some of the challenges from the operation perspective. And no one knows who ran what applications on the Spark. So I want fine-grained audit. So these are all some of the challenges. I think I'm talking more about the challenges. Let's get into the solution. So before going to it, does anyone face any of the challenges that I highlighted here, just to get a quick sense of it? Cool. So many challenges. Okay, then when you when you walk out of this room, you are going with the solution now. So building the SCAS. So the first thing we address is no more edge nodes. I don't want to maintain 250 or 300 edge nodes. I'm going to completely remove the edge nodes. And what we did is replace the edge nodes by Livy. So Livy is an open source Spark job server. 2 years ago, it was part of the Cloudera Hue product. Then later, by seeing the power of the Livy, they spin off that project into an open source project. And currently, they are in the process of Apache incubating it. So Livy job server is the one you can submit the job through HTTP requests, like REST-based interface. You can submit from anywhere. That simplifies the problem. Like you can submit from any kind of languages, any kind of client to Livy, and without change a single line in your code. That's the power of the Livy. So you are submitting on the Spark submit. Say for example, my class name is arc Apache Spark example SparkPy, and my file is Spark example /SparkPy. You can use the same thing to the Livy, and then Livy actually build that Spark submit command for you, and then it will execute on the cluster. So we deployed Livy as part of the cluster so that anyone can submit the job. So no more CLIs and no more installation of all the Hadoop libraries, Spark libraries across the system. User can easily submit the job to Livy. Okay, so Livy was good, but is it worth for the production use case, like where we are running thousands of applications? One of the major problem at that time is Livy does not have the high availability. So, sorry, before that one, anyone hear about Livy so that I need not to go deep dive into it? Okay, so only few audiences. So Livy job server is the one which supports both batch and interactive. you can ask Livy to start a Spark session, and then it will start a Spark context and then give you a session ID to you. And using that session ID, you can send the code. Okay, say for example, I will ask Livy, start a Scala session for me. It will start a Scala session and return an ID 0. And then using that 0, I can send my Spark Scala codes line by line to the Livy, and I will get the sub-second latency that what we record. And in case of SQL, I can start a SQL session, and then I can send the code to execute it. So Livy, at the time, the problem was it's a single point of failure. So if Livy is crashed or Livy, that node crashed, we lost everything. Because Livy internally what it does is when you are asking the Livy to submit a job, it's submitting the job on the yarn cluster mode, and then it's maintaining a mapping between your session ID and then the yarn application. So when you ask Livy, give me the status of the session ID 0, then it will look in the mapping, okay, the yarn application ID is 14356, and then it look at the yarn and send back the status. So, but when it crashes, you lost all the information. So we want the high availability. Then we actually what we decided, okay, let's leverage the Livy and maintain our own PayPal version of Livy. So that's where we started. We added the multi-node high availability, and not like name node like active standby. We went one step ahead of it, active, active, active. So if today we deployed 6 Livy server for each cluster to handle like 10,000 of applications you can submit at the same time. If tomorrow, if 10,000 is increasing to 100K, I need not to worry about it. I just add 6 more Livy to that Livy grid. Everything will be in the active, active mode. And if one Livy is going down, the other Livy will keep on serve your request. So that's one feature we added, multi-node high availability. And then at the time, Kerberos was not available in the 0.1 version. So we added some Kerberos authentication rules for the Livy. And then SQL interpreter. So most of our workloads, as I said, is in the Spark SQL. I want an easy way, instead of each and every step through nwrap it like icontest.sql and then the SQL name, I will just submit the SQL you execute for me. Like you can think about like hive-f, I can give a Spark hive query file, then it will be executed. But in Spark, there is no way of easily submitting that job. You need to every time nwrap it to the hive-context.sql and then run it and then get the result, process it like that. So we wanted an easy way of SQL interpreter, so we added that one. And Spark-SQL CLI maybe do that one, but it will do only in the yarn client mode. That's a major problem. I said a lot of people are running in yarn client and local and bring down that host, but the problem is PySpark, Spark SQL, Spark Cell CLI does not support yarn cluster mode. It will run only on the yarn client mode. So we added the SQL interpreter similar to Spark SQL CLI. Now you can run a SQL file in the yarn cluster mode. And next one is session manager enhancements. So when we are scheduling our jobs through a scheduler, so we don't want to manage like, okay, I submitted a job to the Livy. Livy will be giving a session ID 0, and then I need to use that session ID to submit the next job. I don't want that kind of tracking and shaking process. I want to make like, okay, create a session with a named session like customer. Then in the next step, I can just tell Livy, execute this SQL on the customer session. So that enhancements we made. And then session GC improvements. As I said, Livy maintains all the thing in the memory, like the mapping information. Keeping all the metadata in the memory will bring down the Livy at some point of time. So we need to keep on deleting the older thing. But we want more flexibility in like, if a job is success, delete that metadata within 5 minutes. If your job fail, keep it for 30 minutes and then delete it. If it is running, don't delete it. Like that, we want more configuration driven, and we made the changes. And then plugin logger. Okay, now everything is going through Livy. Why can't I add a plugger to the Livy so that I can track whoever coming to the Livy, what they are submitting it. And then yarn poll rearchitecture. Each and every application, instead of polling to the resource manager, why can't I poll by batch? So let's take an example. I have 10,000 applications running on the Livy. Then out of the 10,000 applications, if I have 10 servers, then 10,000 into 10, that many times I'm polling resource manager to give me the yarn status. So we made the architecture change. If it is 10,000 application, if it is 10 server, then it's only 10 requests. poll yarn for the 10,000 application together, get one time the status and parse it. And then multiple Spark version support. This is one of the most feature our team asks. I want the flexibility to run the same job on different Spark version with easily to submit it. Then now what we did is you can just add -, Spark version or the Spark version parameter, give 1.6.2, 2.1.1, 2.00, and it will run accordingly on the Spark version. And some more authentication like to blacklist some users, and then Docker container. Everything is available in the Docker container. The ultimate, the SCAS framework is available in the Docker container. And then H-based support, and then Livy is no more Spark job server. We went ahead of that one. Why only Spark? Okay, now you can run your Flink job on Yarn. You can run Beam job on Yarn. So that feature we added it. So now, then once Livy is ready, now I cannot ask my user, okay, change your Spark submit job to a HTTP JSON format and submit it. They want a very, when we ask them to migrate it, they want the very easiest way of migration. So we started developing the utilities, start Spark Batch, start Sparkling Water, Spark SQL, and then start a Spark session, and then execute your file using that session, and then finally stop that session. And then we added Python API, Java API, and everything. And then interactive utilities, we added Livy-Spark, where you can tell, I want Scala or Python session. This is replacement for PySpark, Spark SQL, and Spark Cell, where you can interactively run the process. And then next step is we wanted to address the interactive use cases. We done with the batch and the streaming use cases. For the interactive, we added Zeppelin support. So that user will be able to run the Zeppelin queries. Again, it's going through the Livy. These are all the users who are like not very technical guys, but they know some about the coding, how to do it. So they went with the Zeppelin. But they raised a complaint. I want private workspace to store my notebooks. I want private interpreters, easy way of changing the configuration and everything. And last Spark Summit, in one of the sessions from Microsoft, I got impressed how they use Jupyter to run through Livy. Then we immediately added to our thing. So Jupyter is using Jupyter Hub for enabling the authentication. So when you log into the Jupyter Hub using your username and password, then you will get your own private workspace and then the private interpreters for you. And then when you're running the Jupyter codes, the Spark SQL codes or anything, everything is going to the Spark Magic, and then it will go through Livy. And Spark Magic is the open source from Microsoft. And then once we are done, we have a huge users based on SQL. So we added open source Squirrel, or even you can use a DB visualizer, some thick SQL client where you want to run SQL. Again, everything going through Livy. And why not? We addressed everything. Why not the machine learning? Okay, we added the sparkling water. So now user need not to know how to start a sparkling water with which versions. And then sparkling water does not support Spark speculation. Sparkling water does not support Spark dynamic allocation. So do I need to know all these things to start a sparkling water? No. You just ask Livy one command, start sparkling water. That's it. Internally, we will do all the things for you, like what is the version you need, what is the parameter Spark configuration I need to use, everything we are setting it up and starting a sparkling water. So that way, we addressed all the problem challenges for the analyst, developers, and administrator perspective. Let's address for the operations. Now, we added a logger to the Spark process. It's nothing but a simple Spark extra listener. So it will capture all the Spark metrics like what is the driver memory, executor memory, how many number of executors, how many records I read, write, all that information, shuffle information, everything. And this is possible because of Livy. Because Livy, when a user submit the job, it will enwrap the extra listener and everything, and then it will keep on logging to the Kafka. And okay, we added logger from Spark. Why not Livy? So we added a plugin logger to the Livy. Livy now keep on log everything to the Kafka, like what SQL statement executed, who executed, which IP it came from, what is application jar used, what are the configurations used. Everything is in the near real time. It's getting logged into Kafka. And the operation wants to search that log to identify some of the things, so we added the search engine. So from Kafka, in the near real time, we are indexing into Elasticsearch and added a Kibana visualization. So you can go and just search P. Kasinathan. Then immediately it will list all the P. Kasinathan related use applications, what SQL statement I ran, select star from dimcast. Okay, if from the security perspective, I want to know who accessed customer email address column from dim customer table. Now I can go and just search customer email address. It will come everything because Livy is logging completely who are all the users access this table. Okay, now I address the search capability. Now next one is monitoring and alerting. Sherlock is our in-house developed monitoring and alerting tool, but you can easily replace it by InfluxDB or some time series database where you can enable all the metrics from Kafka to Sherlock. Again, all these are Spark streaming job. Each one is a Spark streaming job to log it. So then in the Sherlock, I can go and mention whenever a Spark application named SparkPy is running for more than 10 minutes, send an SMS to my my mobile number. That Sherlock provides that feature. So if I am onboarding an application today and it's a high SLA, I can just set it up whenever this application is processing less than 10,000 records for each micro batch. Spark streaming is everything is a micro batch job level, right? I can set the job level. When a job process less than 10,000 records, send a message, SMS to my mobile number. So that's a feature we added there. And then when the developer facing some performance issue, they want to deep dive into it, then we added Dr. Elephant. Dr. Elephant is the open source version from LinkedIn. So you can go and see it will show red color, yellow color, and green color. You can easily identify, okay, these are all the jobs not doing good. And we are very, very serious in our PayPal. If any of the jobs is in red color, we won't allow it. We will immediately change the configuration, tune it, and then change it to green color. And then our Eagle, again, PayPal eBay in-house developed monitoring tool. And then Spark Web UI, of course, everybody is having access. Grafana and Apache Ambari metrics from Hortonworks, SmartSense from Hortonworks. Yeah, complete product. So here you go. This is our SCAS framework. The complete framework with all the development utilities, interactive application, machine learning algorithms, SQL client, Logger, Kafka, Sherlock, Grafana, and everything. So quickly on 1 minute to recap the benefits. No more CLI, no more edge nodes. You need not to deploy the complete Hadoop libraries and everything in that edge nodes. Now it need to be installed only on the 6 servers where Livy is running. And then configuration at one place. I forgot an important feature. Livy, I have a feature like blacklist configuration. If any of the user mentions like a Spark executor instances, then it will say you are not allowed to use this configuration because we locked in the Livy. That way, I have more control environment, like none of them should change the Spark history server address, the Spark library path, and everything. I can control that one. And then from developer perspective, now it's REST friendly. Well, now with a bare OS Docker, I can launch a Docker and then submit the job to any cluster I want with easily. And then I can start a session, and then I can persist a table like a dim customer, and then in the subsequent process, I can just refer that data frame across the jobs. Now, no more within one job sharing. You can share your persisted data across the jobs, and restartability. If the third SQL fail, just restart that third SQL because everything is an individual job in your scheduler, in your workflow. Coming to the analyst and scientist, private workspace and enterprise integration, Kerberos support, all the tools. And then operations and security, complete logging. So this is what we enable completely. Sorry, I don't have the time. So just to wrap it up, and the PayPal Livy version, we are in the process of making contribution to the open source already. So if you want those entire product, everything is available. Whatever we added, like Kerberos support, we added to the Jupyter. Then we outsourced to open source state. All the multi-node availability, SQL interpreter, everything we are outsourcing. So by that way, you can get everything. So follow us, and I don't have time, but if you have any questions, we can sync up in the offline. Thank you so much. You have questions?
Hello. All right, yeah. So we're opening up the floor to any questions to Prabhu. So feel free to ask. We have the mics over there or we can pass around. At the same time, our second speaker, I believe, is from Comcast. Please come up and set up your computer. Thank you.
Hi, Prabhu. Nice presentation.
Thank you.
How are you managing application-specific configurations submitted to the...
So the default configuration, it's we are setting up like a driver memory to 4 GB and executor memory to 4 GB at most, like which covers most of the workloads. And again, it's application specific. They need to set it up what that executor memory, number of executor they need to set it up. But what we did is we profiled all the Spark jobs and we come up with that, okay, this is the recommended number. If user is not good on the Spark tuning and other thing, this will work. That's a bare minimal recommended configurations.
You mentioned HBase support, and I was curious, you mentioned that you had added HBase support to Livy, and was this just for queries, or was this to integrate into Spark jobs as well?
Oh, sorry, I couldn't get the question.
You'd mentioned that you had added HBase support to Livy,
yeah.
And I was curious if that was just query support or delegation tokens and further.
So when you run the HBase jobs on Spark, right, there is some dependency, like you need to set up the Spark class path, added the configuration and everything, otherwise it won't work. But when you are submitting through REST server, who is going to set up all those things? So that feature we added in the Livy, you can mention my -- job type is HBase, so that for only for that particular job, we will set the Spark class path, HBase configuration, everything. Because doing it globally, what will happen is, if the HBase is down, all the non-HBase jobs will be affected. So that's a feature we added there.
Thank you.
Thank you.
A couple of questions.
Yeah.
For Livy, for your restartability and for high availability, how are you maintaining, where are you keeping track of sessions? Are you keeping track of them in some offline database?
Yeah, not on the database. We are keeping everything on the Zookeeper. We transform the Livy into completely stateless. So everything is configured through Zookeeper, and then all the Livy are sharing the Zookeeper, even the session ID and everything. And we are using Apache Curator for the session ID variables and other things. So we have the developer who developed and contributed to the open source community here, and if you want, we can deep dive into it.
Perfect. Another quick question. Do you monitor user jobs for bad written UDFs or long-running jobs or high memory?
Yes, correct. So one thing we are very clear is no more long-running jobs allowed other than streaming jobs. If you are running some batch jobs, we won't allow you running more than 1 hour. So split your jobs. That way, you won't get the resources and wait, block others. The others maybe get venerated. As much as possible, run as a smaller jobs like that.
I see. But do you enforce policies?
Yeah.
Okay.
Enforcing it,
okay.
yes.
And one last question is, you mentioned logging, so you will capture metrics from both executors and drivers?
Yes,
okay.
everything logging.
Did you have to make any changes to core Spark to get those?
Nothing. Everything is implemented through Spark Extra Listener. All the executor level metrics, driver metrics, everything we are capturing it.
Thank you so much.
Thank you.
So this is all in Hadoop ecosystem. Do you have any use cases coming up to support any other databases like Cassandra with this infrastructure?
Actually, since it's Spark, I talked about only the Spark, but what we did is the same framework for any kind of big data applications. So Hive, MapReduce, HBase, Pig, for everything, we just replace the Livy by Knox so that the complete framework is same for all the kind of applications. For Cassandra, those are all storages. So the compute-wise, all the compute will go through it.
So
but
Cassandra
still,
Spark, I'm saying.
but still, instead of HDFS and HBase, you can use Cassandra, Elasticsearch, everything on the back end.
Okay. My impression was Livy works only with Yarn and Hadoop ecosystem.
We are running on Yarn, but Livy can run the Spark standalone jobs, Spark jobs, everything.
Okay, yeah. Thanks.
Hi. So I have a couple of questions. So
yes.
First one is about when you are running the multiple jobs from multiple users, so how are you managing the processor and memory requirements of one job? Like, are you allowing multiple long-running jobs, or a job, if it is trying to take most of the resources,
Oh,
How are
yeah.
you?
So that's the reason we are tracking all the applications through Dr. Elephant. If any of the job is showing in the red color, then we will deep dive into it. Why it's saying, okay, this user requested 5 GB of executor memory, but used only 1 GB. So it's wasting 4 GB. So we will reach out to them to decrease it. We are enforcing all the performance tuning, maintenance of jobs through Dr. Elephant.
So are you manually controlling jobs
For
right
now, manually, but in the future, we wanted to integrate with Jira so that automatically file a ticket on that.
Okay. Another one is like you said that you are using Jupyter Hub, right?
Yeah.
And Jupyter Hub doesn't support cluster mode as of now, and that becomes a single point of failure.
Jupyter, we enabled Jupyter, and then we actually activating the load balancer on top of the Jupyter. So when the user comes to that load balancer, it will route to one of the Jupyter. So and then the complete notebooks and everything is on NAS enabled. So even if one of the Jupyter is going down, the user can proceed with the other Jupyter, since the notebooks is keep on saving at the real time.
Okay. So another question from Jupyter Hub: are you using any particular spawner for spawning Jupyter notebooks?
We are using Jupyter Hub 0.7 version, I guess, not sure. I can give you some information of the state. Okay. And then we are using configurable HTTP proxy to spawning the user. Okay. So when the user log into the Jupyter Hub using configurable HTTP, the root will impersonate to that user so that all the Spark jobs will be running through that user.
Okay, thank you.
Thank you so much. Thank you.